Oh, hi, this is the Mathization channel on YouTube. Um, June 2025. This is about torque, and torque is a twisting force, such as on a nut, bolt, and here it can also be called a pivot point, too. The nut or bolt does have a diameter, so also has a radius, and it's the greater the lever arm distance, the greater, for a given force, the more twisting power, such as to turn a nut or bolt. That might be a beam or a wrench or something. And in this example, it can go counterclockwise, and of course, this nut or bolt would turn counterclockwise also, such as you're trying to tighten it or loosen it. Okay, the equation for force is mass times acceleration. That's how they explain why there is an increase in force here on the nut. I mean, it's greater than that applied, and it's right here. Okay, and they explain it like acceleration. It's really like complex and stuff. It almost doesn't make sense, but it is true because okay, just leave it at that. This is a simpler way to explain it. And then see, we have power in, that's force times distance right here, equals power out. Okay, force times distance again, but they're not the same values, but they're equivalent in value. These two equations here, this equation, are both sides of it. So force 2 is some factor higher than F1, and it's actually the lever arm distance. So to keep the power out at the equivalent value, you have to divide the distance by n. See, they would just cancel and it's still the same value. So the distance is shorter. See, the distance here at the circumference is much shorter. It's much greater than this distance right here. So it's just, many times greater. And that's explains that, why the force is greater and the distance is of the radius is smaller. Okay, that's a better way to explain it, torque. Okay, thank you.